In this lesson, we're going to look at the first normal form. So here's the definition of the first normal form. That, first of all, the data's in a relational table. So what do we mean by that? That means that the table has rows, it has columns, and it has a primary key. So that's it. So it's a pretty simple definition, but it's very fundamental. And I think the key thing here to remember, no pun intended, is that the table has to have a primary key to make it a relational table. Also, each column within this table must contain atomic values. So let's go a little further into this and see what we mean by this. So a relational table, again, has three components: the rows, the columns, and the primary key. So do you think any of these are relational tables? For instance, would this structure here satisfy as a relational table? My general feeling is no, that looks more like a tree, so I'd rule that one out. This second one here, it's closer to looking like a relational table, but it definitely doesn't have rows and columns. You know, it's more of like a linked list hash table-ish thing, so that's definitely not a relational table either. So a relational table is going to be more rectangular, right, with rows and columns, and then of course we have that series of either one or more columns that uniquely identify the row. So using some data, let's look to see if we feel that this would qualify as a relational table. There's a couple things here that stand out that may make you think that it's a relational table. You could use, for instance, salesperson as a primary key to uniquely identify the rows. I mean, it's fair. Though, true enough, there are people that have same name, but in this example, it looks like that would hold. However, I think where we're going to run into issues is that if you look at the various customer fields, there's values that are separated by commas. And so these really aren't atomic. So I got Ford, which looks like a customer. Dearborn is a city. And then the 94,000 is probably like sales or something. And you can see that again with Dell and being in Austin or Boeing in Chicago. So in my mind, this is not a relational table because it fails on the atomic value aspect of the rule. So let's explore atomic values, because you can split hairs on this a bit, and let me explain what I mean by that. So clearly the number 23 is an atomic value. It's something that really can't be divided down much further. You can say the value green is an atomic value, as you can the city Los Angeles. Now, where we can get into some debate on whether something's an atomic value or not would be like a name. So let's take a full name like George Washington. Would you consider that an atomic value? Now, in my mind, depending on the use, I may be happy with just having full name for simplicity's sake, but I think for ultimate flexibility in the database, I'd be better off having a first name field and a last name field, because what then this would allow me to do then is to sort the information, right? I could sort by last name or sort by first name. Might make searching easier. Also, it would avoid data entry issues where people would enter the name like George Washington, and then in the second example here where someone might enter the name as Washington, George. So I wouldn't really consider that an atomic value in my mind. Now, dates are another one where is it an atomic value or not. So I would consider a date to be an atomic value, but you could argue that maybe you need to have the pieces separated out. I've seen cases in data warehousing where people make special date dimensions that will have as the primary key of their table the full date, and then they'll have the pieces for the year, month, and day. So I think though, as far as a normal table, I would just retain the date. Of course, carbon dioxide is clearly an atomic value. Chicago, Illinois, I would not consider that an atomic value, mainly because Chicago is a city and Illinois is a state. And then for the last example, where we have pizza, breadsticks, and 2 liters of Coke, I would consider that an atomic value, as we're really describing like 3 products within a column. So hopefully this gives you a feel for what are atomic values and how they can be used, and in some cases where there may be just a slight gray area depending on semantics and what the intention of the field is. Alright, so this wraps up our lesson on normalization. Let me just scroll back real quick, because I think it's important that we just go over the definition again real quick. First over form definition is pretty straightforward. Just keep in mind that the data is in a relational database table. It has rows and columns, so it means it's pretty much a rectangular shape to, and then each row is clearly identified using a primary key. And then again, we're not trying to overstuff values into the columns, meaning, like separate multiple values with commas. Each value within a column is, a singular value. It's atomic. So with that, wraps up our lesson on first normal form, and I'll see you in the next one.